This question is about a pendulum. Acceleration due to gravity on Earth were given. The pendulum is set up as shown in the diagram. The length of the cord is 1.55 meters, so that's L. And the bob has a mass of 1.80 kilograms. We'll write that down. Usually that doesn't really matter for a pendulum. Calculate the time for the pendulum bob to swing from one side to the other. So one side to the other, that's half of a full swing. So that's going to be half of a period. So we'll first find the period. So t is equal to 2 pi square root L over g, which is 2 pi square root, and the length was 1.55, and g is 9.81. And then we'll figure that out. So 2 times pi times, and then we'll do bracket 1.55 divided by 9.81. Close the bracket, then we'll take the square root of that. And we get 2.497 or 2.50. So that is 2.50 seconds. So that's a full period. One side to the other is only half a period. So the time t over 2 is equal to 1.25 seconds. This is the time to swing from one side to the other. I don't know if we need to write that, but just to avoid confusion, so this is the answer. Explain how the forces acting on the bob change the bob's speed as it travels from point of release to the center. So we can say, how do the forces change the bob's speed? So we want to explain how it changes the bob's speed. So the net force decreases as it moves towards the center. At the center, the net force is 0 if we assume that it's a reasonably small velocity, if we assume that it's simple harmonic motion as well. Approximately. Maybe we should say approximately. So the net force will... Well, actually, one other thing that we need to say about the net force. A couple of other things, actually. So we can say the net force is the sum of the weight, the downwards weight force, and the tension, which acts at an angle. The weight and the tension in the string. It is always acting towards the center. So now we've said everything we need about the force, I think. So we have said that the net force is decreasing as it moves towards the center. It's always acting towards the center. So now we can say what happens to the bob's speed. So the bob's speed increases as it moves towards the center, but it increases at a decreasing rate. The way that we can say that is that the acceleration decreases. And so the bob speed increases as it moves towards the center. note acceleration decreases. Okay, hopefully we've said enough there. You can check on the mark scheme after completing the question. Okay, the bob is released again in such a way that it swings in a horizontal circular path with a radius 0.290 meters as a conical pendulum. By first calculating the size of the angle that the cord makes with the vertical, show that the tension force in the cord is 18 newtons. Okay, so let's find the angle. So we can use the measurements on here on this diagram to find the angle. So we can say that tan theta, well actually it's not tan theta, is it? So this side here is 1.55. This side here is 0.290. So it's the opposite on the hypotenuse, so it should be sine theta is equal to 0.290 over 1.55. So theta is equal to the inverse sine of 0.290 over 1.55. Let's just check that we're in degrees. Oops, yes we are. Oops, there we are. So we'll go 0.290 divided by 1.55. And then we'll go second function sine. Oops, that's not quite right. Let's try that again. 0.290 divided by 1.55 bracket. And now we can go second function sine is 10.78 degrees equals 10.8 degrees. Okay, there's the angle, and now we want to figure out the tension force. So we know the weight force. I might just sketch a little diagram here in the margin. So we have a weight force of mg and a tension force like that called T, and then we have this is the net force, and this angle here is theta. Okay, I've kind of, yeah, to make it look a bit more similar, you can do tension first and then the weight, and that's the centripetal force there. This is theta, this is mg, and this is the tension. So we can say adjacent over hypotenuse is the cosine of theta. So we can say mg over t is equal to cos theta. So t is equal to mg over cos theta, which is equal to 1.80 times 9.81 over cos of 10.8. So 1.80 times 9.81, and then divided by 10.7834. I'm using that number from memory here, and we want the cosine of that, and that's equal to 17.97 newtons. 17.98 newtons, or 18.0 newtons, we should really say, equals 18.0 newtons. Okay. Calculate the speed that the mass must have been given when released in order to attain a horizontal circular path at a radius of 0.290 meters. So the speed, we need to first find the centripetal force. So the centripetal force we can use this diagram that we've drawn up here. That's this one here. So FC over mg is equal to, that's opposite over adjacent, is tan theta. So FC is equal to mg tan theta, which is 1.8 times 9.81 times tan of 10.7, or 10.8. Which is 1.8 times 9.81 times 10.7834. I'm going to keep using this less rounded number, and then we want to do tan of that, and equals, and that gives us 3.36. 3.36 newtons. And we also know that Fc is equal to mv squared over r. So V is equal to I'll do a little c. Fc times r over m square root, which is the square root of 3.36 times the radius was 0.290 over the mass, which was 1.8, which gives us, so it's that times 0.290 divided by the mass, which was 1.8, which gives us this, and we want to square root that, which is 0.736 meters per second. Okay, what else have we got here? That's the end of the question. Cool, so I think we've solved that.